That was simply wonderful. Even though I'm a primate, with a body clearly designed to live on land, I just love being in the water like this. And this film is about all of this wonderful stuff. It's the story of water. Ordinarily, when you ask a person to think of the Earth, he or she will think of our land masses. The mountain ranges, the prairies, the cities, and so on. But when we look at the Earth from a distance, it is difficult to see any of those things. What you do see is water. Liquid water in the oceans, water vapor in the clouds, and water crystals in the form of ice and snow. It is a world in blue and white. Right now, I'm happily enjoying the waters of Lake Erie, one of the 5 Great Lakes that are such permanent features to the geology of North America. And by switching to this overhead view, we can get a sense of just how large this lake is. As the view gradually gets wider and wider, we can see that this is no ordinary lake. We can see why it's called Great. These Great Lakes, these enormous basins of water, are believed to be geologic remnants of the last great ice age. They are so big that approximately 1/5 of all the liquid fresh water on the surface of the Earth is contained in these 5 lakes. They are places where there is fresh water as far as the eye can see, and where one can swim endlessly. From west to east, each of these Great Lakes flows into the next, and that is something I can show you by swimming to the eastern end of this lake. Now I'm floating out of Lake Erie into the fast-flowing waters of the Niagara River. This is the water flowing downhill into Lake Ontario. That is the Peace Bridge passing overhead. It connects Buffalo, New York on the United States side of the river to Fort Erie, Ontario on the Canadian side. And when I say flowing downhill, I'm not kidding. That is because just a short distance ahead, all of this water is going to tumble over Niagara Falls. So it's definitely time for me to swim ashore and join my friends.
One of the best ways to appreciate water and the power of moving water is to stand at the base of a waterfall. Of course, this isn't just any waterfall. We're at the base of Niagara Falls.
This is phenomenal. We are watching 170,000 cubic meters of water per minute fall 60 meters from up there to down here.
Now, considering all of this thundering water and thinking about all of the energy released as it tumbles down under the influence of gravity, it's amazing to think that only half of the water in the Niagara River is falling down in this location.
That's because a short way upstream, the other half of the water from the river is diverted into large man-made channels that are situated on both the U.S. and Canadian sides of the border. All of that diverted water flows around the Niagara Falls area while staying at the height of the upper escarpment before tumbling down through enormous hydroelectric power plants. It's there that all the kinetic energy we see here in the falls is harnessed and converted by turbines into electricity.
It was profoundly important in the development of civilization that mankind learned to exploit this flow of water.
Before there were hydroelectric dams, people learned to divert water for irrigation channels, for shipping channels, and for many other purposes.
So there's an important aspect of water that's often overlooked without us even thinking about it. Water is both heavy, but it flows very freely. Just think about that. Water may be the only substance in the natural world that has both of those properties. Of course, there are other heavy substances, like rocks, but they don't flow freely. And there are other substances that flow freely, like the gases in our atmosphere, but they aren't heavy. The liquid water of Earth is rather unique in that way.
The movement of water over the face of the Earth from high places to low, like these, has been critical in shaping the face of the planet.
The power of this heavy substance is so amazing that it's actually eroding away the bedrock under it at a rate of about 1 meter per year.
But let's go further downstream so we can talk a little easier without shouting. Over the intervening 12,000 years since the melting of the last Ice Age glaciers, the thundering waters of Niagara River have gradually, or you can even say relentlessly, eroded away the bedrock to create this magnificent Niagara Gorge.
That's right. The location of Niagara Falls is changing. Just take a look at this illustration. This line represents the location of Niagara Falls when European settlers mapped it in 1678. And then take a look at this line. This indicates when it was mapped once again in 1819.
Well, now it's time to shift our attention from one river to another. As a way of illustrating that all the waters of the world are connected, and with the help of some video magic, I'm going to go down in one river and come up in another. I'm going down in the Niagara. And now I'm in the Amazon. Actually, I'm in a tributary of the Amazon. The Amazon is a series of thousands of tributaries that weave in and out of this rainforest. In this part of the world, there is a wet and a dry season. Months when it rains almost constantly, and months when it hardly rains at all. And as a result, seasonal water levels can vary up to 20 meters in the middle Amazon region, and enormous stretches of forests are flooded for half of each year. It is so amazing that even when you're here, it's difficult to get used to the fact that you're boating through the treetops in a way that allows you to encounter canopy wildlife almost at eye level. It's amazing to be here. For me, it's like a dream come true. I'm standing on this enormous floating log in the middle of the Japori River in the Mamirawa Reserve in the very heart of the Amazon River Basin. This is just one of tens of thousands of tributaries that flow through this rainforest. The current here is steady and strong. There's lots of water moving through here. But by Amazon standards, this is just one small side branch off just one tributary. The scale of the Amazon is truly mind-boggling. One way people will describe its size is by pointing out its 4,000-mile length. You get that number by starting at the river's mouth where it empties into the ocean, then tracing backwards, measuring the distance along each tributary. One by one, after innumerable branch points, you reach the point where each tributary begins, usually at a marshy field or on a rain-soaked hillside. And when you do this to the farthest point along the longest combination of tributaries, you call that the maximum length of the river, which for the Amazon is 4,000 miles. But in reality, geographers have recognized more than 1,100 significant tributaries that flow into the Amazon. What if we were to calculate the length of all those tributaries combined? Would that not be an even more fair way to measure a river's length? Well, the total length of all those tributaries would circle the entire Earth about 10 times. It is astonishing. And what about the statement that the Amazon drains an area of 3 million square miles? That entire drainage area is more than the entire area of the lower 48 states in North America. That means that about 1/5 of all the world's surface fresh water is here, an amount approximately equal to all 5 of North America's Great Lakes.
But up until now, we've only been talking about liquid water, and that was intentional.
But now we have to add a qualification to this discussion. In reality, much of the world's fresh H2O is frozen in the form of snow or ice. And 90% of that is in Antarctica, so that is where we will be going next.
We're thrilled to say that we are now in an expedition ship headed south, very far south. We have already traveled to the tip of South America, and we're now sailing even further southward, across the area of the southern seas known as Drake's Passage.
Life on the ship is actually very comfortable, but it's still a little bit difficult getting used to this constant rolling back and forth.
The reason for this rolling is very simple. Let's show you what it looks like from up on deck.
This is a great place to point out an important difference between the North and South polar regions. The Arctic, at the far north of our globe, consists of an ocean of water that is almost completely surrounded by land. North America, Greenland, Iceland, Eurasia. By contrast, the Antarctic, at the far south of our globe, is a continent of land that is completely surrounded by water.
Another perspective on that same geography comes when we focus on our oceans. Land masses make up the northern edge of all 3 of our world's great oceans, but those same 3 oceans are open at the south.
In this region, strong winds blow almost constantly from the west, and let me tell you, these winds are strong. And there is a very important consequence of the pressure of this wind pushing relentlessly on the water. The result is that the water also flows from west to east. This is called the Antarctic Circumpolar Current, and it stretches for more than 20,000 kilometers along the entire coast of Antarctica. This current is very wide and very deep. So even though the rate of flow is modest, it moves an incredible 135 million cubic meters of water every second. That means it carries more than 100 times the volume of water moving in all of the world's rivers combined.
That enormous volume of water, constantly flowing from west to east, is the main reason for the similarities of salinity and other properties of our oceans. Some of the waters of the Pacific, the Atlantic, and the Indian Oceans are constantly being carried from one basin to another down here at the bottom of the globe. Underwater, there are also other patterns that add a considerable level of complexity. Cold water tends to sink because of its greater density. So water that is chilled in the region around Antarctica tends to move slowly downward, and warmer water from further north is very gradually drawn in to replace it. The result is a gigantic conveyor belt that carries heat away from lower latitudes and cold away from higher latitudes. Overall, this has a unique role in the Earth's climate. The polar regions are less cold than they would otherwise be because of the flow of warm water moving toward them at the surface. And the equatorial regions are less warm because of the cold water rising upward from below.
In any event, enduring those very strong winds and rolling seas was definitely worth it. That is because there is nothing that compares to the thrill of reaching Antarctica itself, an entire continent that is almost completely covered in snow and ice. Most of the ice down here originates as snow. So does fresh water, frozen fresh water. Most people are surprised to learn that it really does not snow very much in Antarctica, only about 50 millimeters per year, water equivalent. So in that sense, it's a desert, comparable to the Sahara in terms of annual precipitation. But it is so cold that the snow that does fall almost never melts. So over the course of hundreds of thousands of years, those small amounts of annual snowfall have gradually sequestered an enormous amount of the planet's H2O. Each new layer of snow falls on top of the one before it. And ever so gradually, those snow layers collapse under the weight of the ones above them. The result is that Antarctica is covered by very large ice sheets.
Except that the words very large does not really do them justice. The Antarctic ice sheets are immense. They encompass about 14 million square kilometers. That is an area about as large as all of Europe. They average more than 2,000 meters thick.
There is so much ice down here, approximately 75% of all the world's fresh water is within these immense Antarctic ice sheets. But of course, there is still one very important point to add to this overview of the water on our planet, and that is that most of the Earth's H2O is not found in the fresh water of our lakes, rivers, and glaciers. 97% of it is in the salty water that makes up our planet's great oceans. And to tell that story, it is time for one last change in location, to Hawaii. You know, out here in the open ocean, you get a much better sense of what our Earth is like than what we're used to. And that's because 70% of the Earth's surface is covered in water. So most of our planet looks just like this. Nothing but water all the way to the horizon.
That 70% is an amazing statistic, even if you're just reading it in a book. But for me, the experience of actually being out here is almost overwhelming. It's so vast.
Vast is exactly the right word. 96% of all the world's water is located in its oceans. This is the real face of the Earth. More than anything else, we live on a water world. So let us all embrace a culture in which we treasure this world in blue and white, both for our own sake and for the health of the entire Earth. And now I'm in the Amazon.
Good. That's a keeper.